Special case products. Difference of squares in perfect square trinomials. The sum and difference of the same two terms are called conjugates. So here are two conjugates. Notice everything is the same except you just have the sum and difference. So one is negative, one's positive, one's negative. Basically, they are identical except their operations change. That's the only difference. That's a conjugate. We like conjugates because they lead to difference of squares. So let me read it to you. First special case, when you multiply conjugates, your answer is the difference between the square of the first term and the square of the second term. So a plus b times a minus b is equal to a squared minus b squared. Again, this is called the difference of squares. That's called the difference of squares. What's nice is that if we know this pattern, we can easily multiply these things together because we know that the middle terms are going to cancel out. So if I show you like a plus b times a minus b, you've got a times a, which we know is a squared, then negative ab, then plus ab, and then minus b squared. So the pattern is that every single time your middle two terms reduce to zero. They will always zero each other out. So if you know you've got a multiplication of two conjugates, all you do is you look at the first term and you square it. So this is 9x squared. You know it's subtraction. You look at the last term and you square it. So that's 25y squared. And that's just the quick mental math way to do it. You, of course, can distribute it all out, but just remember that every time your middle terms are going to go away. So pause the video, try 11, and then press play when you're ready. So it will be 25 minus 49a squared. Ta-da! So moving right along to the next page. If we have something like this, say 12, I know that this is r squared minus 4 ninths because that's what 2 squared is and that's what 3 squared is. Remember, 2 thirds squared, we use that distributive property that we learned on the first week of school or at the beginning of the semester, which is 4 ninths because this is 2 squared over 3 squared. Now I'll leave 13 for you.